Okay, we're going to continue looking at integration of trigonometric functions, and this time we're going to use some of our identities to play around with the functions to make something that in the form that is presented, it's not we can't integrate it, but it's a form that we can integrate. So let's just have a quick review of some of the functions that we've already, some of the trigonomic identities that we've looked at, and have them so that we can use them in our integration. And I'll keep them on the screen whilst we work with our integrals. So we know that cos 2x is equal to 1 minus 2 sine squared x, and we can rearrange that to give us sine squared x is equivalent to a half 1 minus cos 2x. And we know that cos 2x is also equivalent to 2 cos squared x minus 1. And rearranging that, we get cos squared x is equivalent to a half 1 plus cos 2x. So we're just going to leave these here whilst we work. So let's find the integral of sine squared x dx. So we'll substitute in for this. So that will give us a half 1 minus cos 2x dx, and integrating that we get x minus a half sine 2x plus c, and tidying that up we've got half x minus a quarter sine 2x plus c. Let's integrate 3 cos squared 2x dx. This is a bit more tricky. So here we're going to use this identity here. So we will take the 3.5 out here, and we will have 1 plus, now this is cos, here cos squared x is a half 1 plus cos 2x, but we've got a 2x in here already, so this is going to become cos 4x, because the 2 times the 2 dx. So this will give us 3 over 2, our 1 becomes x, plus, this is going to be a quarter, sine 4x plus c, and tidying this up we'll get 3 over 2x plus 3/8 sine 4x plus c. Let's find something a little bit more tricky. So this time we're going to do sine to the power 4x dx. Now we know sine to the power 4x is the same as sine squared x squared. And sine squared x is this. So we can substitute that in here. So we can have a half 1 minus cos 2x all squared. So this squared is a quarter. And this we're going to expand. So we'll have a quarter. This will become 1 minus 2 cos 2x plus cos squared 2x. But for this bit here, we know that cos squared 2x is going to be a half 1 plus cos 4x. So we're going to substitute this into here. So all this gives us a quarter 1 minus 2 cos 2x plus, that's a half, plus a half cos 2x. That's meant to be a 2. Oh, that's meant to be a 4, sorry. Because it's a 2x there. We have 4x. Let's tidy this up a bit because it's very messy. So we'll get 3/8 minus a half cos 2x plus an 1/8 cos 4x. And now then we can now take this here and substitute it back into original thing. So all that working, and we've not even done any integration yet. So it's going to give us 3/8 minus a half cos 2x plus an 1/8 cos to the power cos 4x dx. And now we can integrate this. So it'll give us, a square bracket actually, so this will give us 3/8 x minus, so this will become, this stays minus, so that's the 2 here becomes a half times this half is a quarter. This will be sine 2x, and this will be plus, so we're going to have a 4 divided by an 8 is going to be a 1/32, not sine, not cos, sine 4x plus c. Always remember the c. Let's add in another identity to our little list up here. So if we wanted to integrate tan squared x, how would we go about that? So we would use the identity 1 plus tan squared x is the equivalent to sec squared x, and that then leads us to tan squared x is equal to or equivalent to sec squared x minus 1. So using that, we will now do another couple of integrals. So let's find the exact value for this. Between 0 and pi over 4, we've got 5 tan squared x dx. So we're going to use this. So we're going to, our integral between 0 and pi over 4, I will take the 5 out here, and that will give us, actually we'll keep the 5 in this time because we're doing a definite integral. So this will be 5 sec squared x minus 5. So just kind of multiply through by 5 for that one. Dx. Now we can integrate. So we know the integral of sec squared is tan, so that's going to give us 5 tan x minus 5x, which will be, so the 5 and the tangent of pi over 4 is 1, so it's going to be that, minus 5 pi over 4 minus 0, because 0 and 0. And that's going to be our answer. And we'll just leave it in that form because it's the tidiest form to do it in. Let's do another example. So firstly, we want to show that y equals sec x, so that if y equals sec x, then dy by dx will be tan x sec x. And secondly, hence find the exact value of 0 to pi over 4 cos 2x plus 5 tan x sec x dx. Now when you see a question that's got hence, you know that the answer to your first bit is going to inform the working out of the second bit. So even if you struggle to integrate this, you'd be able to see you're using the fact that integration is the opposite of differentiation, and you know, if you know that derivative dy by dx is tan sec x, you've got a tan sec x here, so you're going to be going back to the sec x. But we're jumping ahead of ourselves. So if y equals sec x, well, what is sec x? Sec is the inverse of cos, so that's the same as 1 over cos x, and here we can use the quotient rule. So dy by dx is going to be cos times 0, because integral of 1 is 0, minus 1 minus sine x over cos squared x. So here we're going to get sine x over cos squared x, which is the same as, we know that the 1 over cos, the inverse of cos is sec, so, and sine over cos is tan, and that's what's tan x sec x. I'll just write those over here. So we already know that 1 over cos is sec, but sine over cos is tan. So now we've proven that, we can now go and do our integral. So this is going to be a half sine 2x, and here this is going to give us, if the derivative tan times sec comes from y equals sec x, then that's going to be 5 sec x. 0 pi over 4, and that's then going to be, by substituting in our limits, we'll have half plus 5 root 2 minus 0 plus 5, and that's going to give us 5 root 2 minus 9 over 2. do a couple of more. So again, it's very similar. If we're going to use the answer to one of the first part to help us with the second. So first we're going to prove that 2 cosec 2x tan x equals sec squared x. So let's think about what we know. We know that tan x is equal to sine over cosine, and we know that with the double angle theorem, sine 2x is equal to 2 sine x cosine x. So let's look at the let's look at this 2 cosine, oops, that's a mess, 2 cosec 2x tan x is going to be the same as, we've got our 2 and our tan here, and cosec is the inverse of sine, so that's going to give us sine, and it's 2x here. And now we're going to substitute in for our different identities. So tan is sine over cos, so over 2 sine x over, I'll put the cos x over here, and sine 2x is going to be this, so over 2 sine x cos x. And we can cancel out these signs, so that's going, and we can cancel out the 2's, so it's going to be 1 over cos squared x, which is the same as 1 over sec squared x. Put the line there. So the second part is hence, that little word hence again, find the value of between a third pi and plus third pi, minus third pi and plus third pi, 5 plus cosec 2x tan x dx. So here we've got this, which is the same as, I've got 1 over sec x, that's wrong. This is the same as this, so we can substitute in. And because this is just, there's no 2 here, the 2 there, so it has to be a half sec x squared. And so it's going to give us 5x plus, the sec is going to be sec squared x, the integral is tan, so it's going to be a half tan x and we can then find this out, so 5 pi over 3 plus, this will end up being root 3 over 2 minus, oops, Again, 5 pi over 3 minus root 3 over 3, and that tidies up to give us 10, 110, 10 pi over 3 plus root 3. And we leave it in that neat, nice little form. Let's do one more. So this time we are going to use the expression of cos 3x minus x and cos 3x plus x to show that cos 2x minus cos 4x is equivalent to 2 sine 3x sine x. So we know we need to use these two things. How does this and this relate to this and this? So if you think about it, cos 2x is the same as cos 3x minus x. 3x minus x is 2x. And then we're going to have minus cos, this is 4, so it's 3 plus 1 is 4. And so we can then use the identities that we already know to give us cos 3x cos x plus sine 3x sine x minus cos 3x cos x minus sine 3x sine x. If you tidy all that up, you get 2 sine 3x sine x. Now we want to show that the integral between 0 and pi over 4 of sine 3x sine x is equal to a quarter. So we know that sine 3x sine x is going to be a half of this. So we have remember this 2, put the 2 here, and that's going to be cos 2x minus cos 4x dx. And don't forget your limits of integration. So that's going to be a half sine 2x minus a quarter sine 4x substituting our limits in, we'll get half minus 0 minus 0, which gives us a quarter, is which we wanted to show. So I hope that helps.